whose real name is Ecg Teller, and he has a bachelor's in computer science and a master's in computer science from Stanford University and a PhD in artificial intelligence from Carnegie Mellon University. And he's been the founder and CEO of Body Media since 1999. I don't know if you know about Body Media, but it's a company that sells devices such as the one up there that let you monitor physiological signals in real time. He has an intriguing personality. He's an inventor, a scientist, an entrepreneur, a science fiction writer. So I'm sure he will deliver an excellent talk today. So please help me welcome him.
Thanks. I'm going to start in a way that I rarely do by talking about the name of the company. We were just talking about the name of the company before the talk started, but it's relevant, I think, to a talk to Microsoft. Usually, Body Media, the name of our company, talks to people in the health space. And so what we talk about are health things, and much of what I will talk about today will be about health information. But Body Media was named Body Media because the vision of our company is not to be a health company, but to be a body information company. And so what I'm going to try to do today is, on the one hand, tell you our standard story so that you understand where we're coming from. I think it's important even to understand the broader context, to understand where we believe is the right place to start in body monitoring. But at the same time, I'd like to try to weave in a discussion which I think will be particularly topical to the researchers and business people at Microsoft, which is what beyond classic health information and health care is there going on. Not that Microsoft can't be interested in health information, but there's a lot more out there. So that's why we called it Body Media, and I will see what I can do to work some of that in. But to capture that same thought, we are interested in new information. Let me start with what it looks like what the problem looks like in the health space. This is a fact, though it's hard to swallow. We spend 2/3 of our healthcare costs, $1.2 trillion a year. That's where the costs come from, most of the costs, from how people live their lives. The other third comes from their genetics. Now, that shouldn't be possible. There's no way that there's actually $1.2 trillion a year of cost, which is going entirely unmanaged. Right? The stats must be wrong. Maybe everyone's stupid. Oh, it's not that they're stupid. We know that they're not stupid, right? Maybe they're evil. That's actually slightly more possible. Okay, we know they're not evil, but maybe the incentives in healthcare are so perverse that people want the management not to go on. I don't believe that's the truth either. I believe what's really going on, we believe what's really going on, is that you just don't manage things you don't measure. That's true in manufacturing, it's true in science, it's true in every aspect of our lives. Why would it be otherwise in healthcare? So, we know nothing about that problem, the real problem. But if this, understanding the human body, is a bottleneck, a gating function for managing that $1.2 trillion a year of cost just in the United States, it would be pretty interesting to solve this problem. So that's the first thing to understand about Body Media. We are not a human state management company. We are enabling human state management. And I will talk about a number of ways in which we're doing that. So here's the problem. We have had very smart people working for a very long time, very good-naturedly, on body monitoring. But they've made certain assumptions that weren't crazy, but are limiting, and I think their time has passed. One of the assumptions was that the world is a very complicated place. And when you're trying to engineer a solution, that's bad. So what do? Well, why don't we cut out 99.9% of the complexity? We'll bring people in to our labs, and we'll make them lie down, and we'll glue the electrodes to them. Don't move. Don't do anything weird. then there won't be any noise in my signal, right? Because noise comes from two basic categories. There's noise like my sensor doesn't work noise, and then there's the real kind of noise, which is it's signal, I just don't know what it means, and it's overwhelming the thing that I'm trying to find out. That's the real kind of noise, and the world is full of that kind of noise. So we've prevented that. But that begs the question, what's going on the other 99.9% of our lives? And we've punted on that in an attempt to answer some question without having to solve the really hard problem. The other thing that's gone on, again, an assumption which isn't crazy, but I think whose time has passed, is if you look at individual sensors, I know this doesn't look like an individual sensors, it's a very large collection, though, of individual sensors. We look at a sensor from the human body, pulse oximetry, ECG, cholesterol, it can be taken in real time, it can be very periodic, and we ask the question, what's going on inside the human body? We build a model of the human body, we look at how the human body is producing those signals, and then when we see a signal on a new person, we run the model of the human body in reverse and find out what must be going on in that person's body to produce that signal. This plays to the strengths of doctors because it's pattern recognition, and that's what people are good at. But it misses something which computers are really good at, which is counting. Now, it sounds pretty boring. A slightly fancier term for counting is statistics. This is Body Media's goal in life, is to break those two assumptions, to say, what if we were willing to tackle the complexities of the world, and what if we were going to punt on pattern recognition in the classic human sense and to do some counting instead, some statistics? And what could we get by changing those two rules? So we'll get into, in some detail, how we are trying to solve the problem. But let's first make sure we can describe what the problem is. Right? Let's hit the value proposition before we hit the technology, because that's the right order in which to solve these things. So the value proposition is the physical and mental states of people in real time and over long periods of time. If you could see what was going on with all the bodies in this room, now, when they're back at their desks, when they're asleep at night, in the moment, but over the last 5 years, could you change how weight management is done? Sleep management, rehabilitation, entertainment? Could you change effective computing, turning the lights off in your house when you fall asleep at night? What wouldn't change if you had that information? It's going to be hard to get that information in ways that people will put up with, but if you had that information, everything would change. And that's what we're trying to get at. So, just to give you a little bit of background so you know where we're coming from, 5 years old, 4 commercial product lines. We're a venture-backed company. Our mission statement, I think it's worth pointing out here, we are trying to enable these new industries. We're not trying to be a new industry. We are trying to create an operating system, which hopefully will resonate at least in this room, for physiologic monitoring. We're trying to create a set of information services on top of which applications can be built, mostly by people other than us, to solve the thousands of new interesting problems that can be solved once you can see the physical and mental states of people in real time and over long periods of time. So this set of slides I think is very important, but it's very hard for me to do so that it doesn't sound like I'm patting myself on the back with both hands. The International Design Society of America, Industrial Design Society of America, has an international award run with Business Week. It's sort of the Oscars of consumer product design. And there is a similar kind of Oscars of medical device design, which is run by MDDI, which is an international magazine, the medical device and diagnostics industry. We would argue that in order to really win in the body monitoring space, you have to have a perspective which is non-traditional. You have to actually make things which on the one hand are like Medtronic serious. You got to be right. It can't be like kind of right. It can't be pedometer right. It can't be heart strap most of the time right. It's got to be really good. And it's got to be validated. You have to really go over the regulatory issues, the liability issues. But on the other hand, you have to hit this highest level of consumer electronics product sensitivity. You have to iPod, sorry for the metaphor in this particular room, but you have to iPod the product as well. And doing both of those is not something that comes naturally to either of those groups. I think it's pretty interesting. We are the only company in the history of the world to have won both of these, the top honors in both of these areas for the same product. Now, there are companies very large companies sometimes, which have one in different areas for totally different products. But we're the only one who's one for the same product. And I would actually argue this is not because we're so good at what we do. We're quite good at what we do, but that's not why. I wouldn't be surprised if we're the only people who ever applied in both places. We have a set of sensibilities, which I believe is more powerful than our intellect, our particular know-how. But these sensibilities are critical because we have blinders on about how these problems need to be solved, and it's only by taking those blinders off that I think you can make really good traction. Another set of challenges to making progress in this area, you know, there are people who are smarter than we are about biomedical sensing, for sure. I don't know if there are people who are better than we are on the wearability front, but you have to be good at wearability and biomedical sensing. But actually, that's not all you have to be good at. You have to be good at usability. You have to understand the anthropological and sociological issues with asking somebody to wear something too, which is not expressed in a wearability map. You have to worry about fashion issues. Capturing all of those things, again, doesn't come naturally to the classic groups that are working in this area because it draws from so many different disciplines. So, we've talked about what in principle would be great to have, this sort of physical and mental states of people. What's it going to take to really do that? All right, first you're going to have to choose at a very basic, kind of axiomatic level. Do you believe putting sensors in every room of every building on the planet is the right way to solve this problem? Some people do, and that's okay. We happen to believe that that is impractical. But you're going to either instrument the world or you're going to instrument the people. And we would choose to believe that you're going to instrument the people. But one way or another, you have to get information from their bodies. So let's say, for today, that the right solution is to put the sensors on the people. Okay, well, we just talked about some of the challenges associated with doing that. This is non-trivial. But once you do that, disaster has occurred. Because right now, we don't know what's going on with our bodies while we're doing this. But at least it doesn't take any time for us not to know. As soon as you do this, you have produced for people 100,000 times as much information as anybody has ever seen about normal people out there in the real world just doing their thing. Now, it's totally useless and it's overwhelming and frustrating. Okay, so we've gone in reverse. You have to take that fire hose of lower level vital sign data from many different sensors many times a second. You have to distill from that fire hose something of value. You have to take data and turn it into information or you've wasted your time. So this is the core of our company, and I'll talk more about how that works. These two things together I would sort of call the creation of the physiologic information services, but ultimately you have to present the information. And how physiological information is presented is very different, even for the same statement about a person, is presented in different ways for the same person at different times, or for different people but for the same problem, a patient and their doctor, a high-performance athlete and her coach, whatever that would be. So this is the last mile problem, or if you prefer to think of it this way, this is the operating system, these are the applications. So these are going to change a lot more and be more of than these. You guys, by the way, can ask questions. I know there are people watching who can't, and that's their punishment for not having come to the talk in person. But you guys can ask questions. We don't have to just have me be a talking head the whole time. Anything?
I'm curious about at what point do you get design involved with the collection and the processing of information?
Great question. Actually, I am one of the 4 founders of the company, but I'm not the only founder. One of the other founders is over there, Ivo Stavorik. And of the 4 founders, 3 of them are designers. Only one of them, myself, is an engineer. I was actually the odd man out when we started the company. The entire company has been structured around the concept that design thinking, properly applied, is the right way to solve these problems. So we don't bring design in, we bring technology in, and we try to delay bringing the technology in as late in the process as we can until we have solved the right way to solve these problems. Now that takes a set of very special designers who really understand technology and who don't lose themselves, as, no offense, many designers do, on their side of the world, just like technologists can sort of go down these rat holes of making things they think are cool without ever figuring out no one's going to want it. Designers can make things that they think are wonderful without figuring out it can't be built, or that, you know, its elegance is sort of disconnected from real world issues. But we think we have that set of designers, and that's how the whole company is structured. That's a great question. Platform for body monitoring. We can come back and talk about some of the nitty-gritty about, seeing your information in real time on a watch, on a cell phone, getting information from weight scales and blood pressure cuffs and glucose meters. The thing that I think is most important about this picture is the size. I noticed this after we made the picture, but I think this is so telling. The size of this person is just bigger than the caregiver, much bigger. I challenge you to go look at 10 telemedicine presentations. Just go on the web, look. This person will be bigger, 10 times out of 10, than this person, and this person will be right there in the center, and this little dude's going to be Pluto over here on the edge, like floating out into the ether, because he barely matters. And you know why this person doesn't matter? Because all the body monitoring people, really, so far, have come from the perspective that they're being told by their bosses, where are we going to get reimbursement from? That's the question in healthcare. So as soon as you ask that question, the obvious answer is, well, geez, if we're going to have reimbursement as the gating function for this entire project, then we are building this not for this guy, because he doesn't decide whether something gets reimbursed, but for this guy, because he's the one writing the script, right? And that's why this guy's been in the middle. If you start by thinking about this as the important person, everything changes. Now, to this particular audience, this may be slightly more obvious than for many people in the medical world, but even so, I would suggest that we have an innate and implicit thinking that needs to be undone about this person not being in the middle. It doesn't mean that they can't be connected. Just, again, to give you some background about body media, and I'm giving you all of this so that when we get into the technology, we are not just having a sort of disconnected technology talk, but you understand the world in which we think we live. Body media has enough to do, as hopefully it's now clear, we've set ourselves a fairly big challenge. So we're a technology company. We're an intellectual property house that builds things. We don't do sales. We don't do marketing. We don't distribute the products. We don't sell them to anybody. We build relationships with people who are the best in the world at diabetes, or at selling scientific research products, or at selling into the health club market. And it is through those other companies, they help us understand their market. They give us marketing specs. We build the application for them, sometimes with contributions from them, and then they go sell it, often with their name on it, and ours is some sort of ingredient brand. So just to give you a background on how our company operates, we're serious about being more of the operating system and less of the applications company. So we talked about some of these. This is what we would consider the core physiologic information services. And one of the things I think is an important takeaway here, entertainment is not on this list. It doesn't mean that entertainment couldn't be changed, won't be changed. It clearly will by the information about what's going on with the human body. But it won't be changed first. Effective computing, changing the thermostat in your house to try to change somebody's state while they're awake or help them sleep better. Or you guys have heard 1,000 of these videos, and you've made half of them. Those will happen, and in the end, they may be the most powerful aspects of monitoring the human body, but they will not happen first, because no one will wear something 24 hours a day so that the lights turn off when they fall asleep at night. But once they have it for another reason, there are 1,000 cool things that you can do. Just like the internet couldn't have been the first application on the PC, but it's now the most powerful, right? You had to start with VisiCalc to sort of get things going a little bit, and that was a really self-contained reason to have it in your home. And then everything else could build on top of it. These will be the things, not all of which are healthcare, by the way. Some of these, like sports and fitness, the transportation industry, but these are really compelling and well-contained reasons with cost savings, life-saving benefits to have it on your body. Everything else will come afterwards, is our view of the world. We are currently in these spaces, clinical weight management, scientific research, home care, and weight loss and fitness in the gyms. We can talk about those more. These are just some montages of the kinds of things you would get. I'm going to let you ask questions if you want, or we can come back to these. But these are just a sense, for example, of what an end user might see in a scientific, this is scientific research. This one is in clinical weight management. This one is in the health clubs, working with a personal trainer, etc. All right, let's dig into the data. This is one of the things I'm most proud of in the entire company. I just think this is phenomenal. And this isn't because of me. It's actually because of Ivo and the designers. This is why we started the company, because we knew a way to do this. This is sort of a fairly recent snapshot of all of our customers' data. So this only includes people who are paying us indirectly through our channel partners for the privilege to wear these products so they learn about their bodies. Yeah?
What's the sample size?
It's several thousand. I don't know exactly how many. And it may have been a sampling, but it is many thousands anyway. Yes?
How are you getting a hold of this data? And is there a consent from the end users to get it?
Yes. First of all, all the privacy policies are with the channel partner, not with Body Media, because ultimately, if you were buying a product from somebody, you need to have a relationship and a trust with the person you are directly buying it from. But all of our channel partners' privacy policies say explicitly that Body Media has the right to look at anonymized versions of the data and aggregate views of the data. And I'm actually going to get into this in a good bit of detail because there is something incredibly powerful we are doing for the end users. But to give you sort of the brief for right now, the position Body Media takes is we're a data bank. Your data comes and lives in our servers. And part of the reason it does that is so we can turn all that raw data into these distilled nuggets of tremendous value for you. And we will keep your data like Fort Knox. You want us to erase it? We'll erase it. We don't need to know your name or where you live or any of those things in order to create the value for you. And this is an example which is more interesting to this crowd, but you're going to see ways for us to create value for the end users in aggregate by having their data. Does that answer your question, sort of? Okay, so what this says is 75% of the people wear it 10 or more hours a day. These people mostly have had the product for more than 3 or 4 months. This is not people on day 2. I mean, there are people in there who've had it for 2 days, but not the bulk of them. This is phenomenal. People don't have their cell phones in their pocket this much. People don't keep their watches on this much. There's nothing I know of that hits these same things, yeah?
Are they people like have health problems or just a normal people?
It differs because these are different customers. Some of these people, for example, are morbidly obese. So they have a health problem that would make them motivated on the one hand. On the other hand, people who are morbidly obese are sometimes hard to motivate to get, for example, to wear a product. So I would still consider that a success. Some of these people are actually trying to gain weight or bulk up for some kind of fitness thing in a health club. So they have a desire, but not necessarily because they're going to die.
So I wore it for 3 days continuously, except for taking showers, and I ended up with a really bad rash.
Really?
Like a week. So is this like just a one-time usage, and then you don't know if they stopped wearing it that long, or is this a continuous kind of?
No, this is everybody who is currently wearing it. So some of these people have worn it for 3 days, and maybe you would be one of those. You know, we'd really like to talk to you afterwards. We've had about 6 of those cases, and we're still trying to chase down what that would be. So we'd actually like to talk to you afterwards. If you, I'm sorry to say this, but if you could repeat it, we'd be very interested. But no, these are people, most of whom have been wearing this for 3, 4, 5 months. Which is typical. This is just another sort of different view of the same thing. People tend to wear it more during the day, but about 20% of the people actually wear it 24 hours a day, which, again, I think is a huge success. Yeah?
I think her question, if I'm not right, is what she was wondering is if it was a snapshot, or was this cumulative, like mean of, so say in Mary's case.
No, it was a snapshot. It was,
okay, so
it was a snapshot today.
Okay.
What percentage of people are wearing it?
This amount of time.
Right. When we look over the last day, how many of them who have uploaded, say or show that they've worn it this many hours a day?
Okay.
Right. Here's another pretty exciting one. We're getting more data. That's sort of what you would imagine as our business picks up. But there's something incredibly exciting about this. We are a data company. I'm going to talk more about how we take this information and recombine it using statistical machine learning techniques. But that we're getting this data to exponentiate is not just an exciting opportunity for us, and it is. This is the gold dust, and we're getting it for free to make better algorithms. But our end users, by giving us this data for free, are creating, if you like, a network effect with each other, which we're facilitating through statistical machine learning. As they give us their data, we make better algorithms. There is nothing we can do with their algorithms. No one we can sell these algorithms to except current wearers of the armbands. And when we offer it back to them, that promotes more people to have armbands because we can say more about that population. Once we do that, they're sending us more data. And it is a very virtuous cycle which ramps up, as you can see, quite quickly. So it is one of our main tasks in-house. We used to just get labeled data all the time from researchers, right? So we were in this sort of statistical machine learning mode of supervised labeled machine learning. Now we are getting much more into the semi-labeled, unlabeled, implied label machine learning kind of thinking because that's where the future of the company is, clearly. These are some of the places we're going to be in the near future. I'll point out assisted living, home care, infant monitoring, corporate wellness. There's some interesting examples, cardiac care. Okay, so there. Let's talk a little bit about what we're actually doing at a technical level. We're looking at a set of sensors, and I wish I didn't have to show this slide, but I get lynched if I don't, so I've learned from painful experience to just put it up there. This doesn't matter. I mean, you guys are technology people, so you may be interested. But from the end user's point of view, this doesn't matter. This is a set of signals which we're looking at 32 times a second, and it is totally uninteresting to end users. It is totally uninteresting to any caregivers we can find. So why are we bothering? Because they have statistical properties. The way they interact, they have been chosen for their statistical properties. And I'm going to talk about what those statistical properties are. But we are harvesting, using statistical machine learning techniques, the relationship between how these things fluctuate relative to each other. And that makes them interesting for us. So this is what we record, not what we report. This is the data, not the information. We are also getting information wirelessly from other products. So, for example, our customers today buy Roche glucose meters, Tanita weight scales, Omron blood pressure cuffs, etc., that talk wirelessly with the product. So if you were to prick your finger, take a little reading on the Accu-Check meter, the armband now knows what your glucose level is. 2 weeks of memory, 2 weeks of battery power, 16 megahertz onboard processing. It's sort of a low power equivalent to Bluetooth, but it's our own proprietary protocol, mostly because it's lower power. So the physiologic information services, these are the things which we are commercially offering today. Not the complete list of things we are going to be offering, but this is a snapshot in time of what we're currently offering. Some of them, like energy expenditure, like sleep, are against medical gold standards. You put people in a lab and you have the polysomnography, that guy at the beginning that was all wired up, that's what polysomnography looks like. So you put lots of people into laboratory environments, get the right answer according to the medical gold standards of polysomnography, collect raw data from our devices, and then build statistical machine learning relationships between the two so that you can get close enough that you don't need all that glue and all those adhesives and all those lab spaces and all those lab techs in order to say, within a few points of what polysomnography would say, when they're awake and when they're asleep. Similarly, with energy expenditure, you would do the same thing, only you would use a VO2 machine, sometimes called a metabolic cart. You could use doubly labeled water out in the real world. For some of these things, like exercise identification, we are very accurate at telling when someone's walking, when they're jogging, when they're riding in a bike. We're auto-journaling a lot about their lives. And we get the right answers there by paying people, or arm-twisting our employees, to give us self-report where self-reports can be accurate. I can say quite accurately when I'm on a bike and when I'm not on a bike. So, we can trust me as long as I'm not goofing off. And similarly for, say, lying down, you can't ask me to predict when I'm asleep because I'm unconscious when that happens, so I don't really know. But I can say pretty reliably when I'm lying down, so that's a piece of information we can get from self-report. So this is all mostly supervised machine learning from labels that we're getting both from scientific research labs and from self-report that we control or sort of promote. And this has taken on now about 70 million minutes of human physiological data. Though, as you saw, that's going up quite quickly right now. So, to the research community, to the clinical community, we say energy expenditure. You can do that for weight loss. Maybe you could help somebody, run a marathon more efficiently. You could make sure that the elderly people in the semi-independent living aren't being starved by really understanding how many calories they need. Those are all applications that you could build on top of energy expenditure. To this group, I'll say that's just the surface that the health community wants to hear about. The bigger news is this is all context, and these contexts could be used in ways I'm sure we haven't even imagined yet. Maybe you guys have, but we haven't yet. But that's, I think, an opportunity that's hiding in this is having auto-journaled people to this level and doing more every day. What could we now do with this kind of automatic journaling?
Can you tell me, what is motoring duration? Is that like automobile?
Yeah, we don't know that you're in an automobile if you're in a bus. That's why we call it motoring. We don't distinguish between when you're driving and when you're a passenger. It's when you're in a moving vehicle. That's what motoring duration is. It turns out, interesting example, we built the motoring duration thing because we wanted to make sure that unlike pedometers and motion monitors, we weren't giving you credit for a 30-mile-an-hour jog, right? So we built this thing so we could filter it out, and then of course it turned out almost immediately that people were interested in the fact that we could say that you were in a moving vehicle. I'm going to take you very quickly and at a very high level through statistical machine learning. It's an intuition starter, nothing more about why this is interesting. But if you were to look at somebody's motion, as I was just joking about, okay, imagine you're on my waist and you're a little motion monitor. You're that pedometer or whatever. Maybe you're on my arm. It doesn't really matter. Okay, your call. You see this. Am I in a moving vehicle? Maybe I'm jogging. It's really hard to call. Suppose you see kind of like this. Just a little bit of stuff. Am I washing the dishes maybe? Maybe I'm playing with my kids. Maybe I've got a 100-pound backpack on and I'm walking up a steep hill. I'm working really hard. You don't know. The world is ambiguous. This is back to what I said right at the beginning. The world is just a confounding place because there's so many different reasons that this could happen. And I'm not just making fun of motion monitors. Suppose my heart's going like this. So am I watching a Stephen King film? Maybe my boss is yelling at me. Maybe I'm going for a jog. You don't know. But if you could see other dimensions at the same time, you could disambiguate these states. It's sort of obvious once you see it like this, that high motion with your body producing and releasing more heat, it makes it a lot more likely, statistical statement, that you'd be aerobic than that you'd be in a moving vehicle. Now, it's not as simple as this. It is rarely linear in these ways. The splits are rarely perfect because there's so much complexity in this data. But in principle, this is the way it works. And so someone could say, wait a second, if you have a lot of heat but low motion, sure, maybe you're walking up that steep hill with a backpack on, but maybe you have a fever, okay? And so you can introduce more things that help you further disambiguate. So that's what's happening with a person. Now let's ask the question, how much of something is happening to the person? If you look at this measure of somebody's motion, walking up 10 flights of stairs, taking the elevator down, walking around our office building twice, and walking up the stairs again, it looks like it's harder to walk around the block, but we all know that that's not true, right? We would all rather walk around the block than walk up 12 flights of stairs. But the motion monitor's not getting it. If we could see the rays you are producing and releasing heat, something else could be gained. Whoops. You see right here, heat happens after the spike of motion, as you would expect, and there is a long delay trailing off, so you're going to have to kind of integrate under the curve and back project things. Again, non-trivial, but you could use these two things in combination to get a better estimate of how hard somebody is working than you could just from motion. And of course, you don't have to use just these two things. You can use other signals as well. Yeah?
Hi. This may be a stupid question. I'm just wondering, does like a supervised learning has to be calibrated for each person or each type of person, that kind of thing?
No, I mean, one of the things that we do is the input to the algorithm includes your height, age, weight, and sex. So we have demographic information. There is opportunities to further learn by watching a person, but even when you don't do that, by having seen hundreds and hundreds of people over millions of minutes of data, where some of them were women and some of them were men. Some of them were skinny and some of them were large, and some of them were tall and some of them were short. We have a fairly rich space, and we have learned an algorithm which has learned the shapes of that space. You fit somewhere in that space. We don't have to learn again about you or calibrate to you in order to be pretty good at saying, knowing your height, age, weight, and sex, and now watching your specific physiological output, 32 times a second, where you fit into that space.
Okay, thanks.
And of course, we're not keeping the whole space. The whole point of machine learning is to create a model of that space, so you don't have to keep the 70 million minutes worth. Here are some of the things which we are developing. Some of these things, like ECG from the upper arm, a continuous core body temperature, REM information. These are all sort of coming out of our pipeline right now. Relative glucose is a little bit further back. Some of these things, like mental stress, we could actually do that quite quickly, but we haven't found a partner that wants to sell it. So at a certain point, the way body media works is we get it ready enough, we know we could do it. We have the sort of demonstration, and then we stop. And then when somebody says they're ready to take it to market, then we'll take it the other half of the way. Now, in a couple of these cases, getting ECG in a way that people would wear 12, 18, 24 hours a day was so obviously powerful. We've been waiting years to find a way to do that, that we didn't wait for permission from our partners to go do that. Same with relative glucose levels. And I want to stress, this is not the HGs per milligram. What this is you are hyperglycemic, you are normal, you are hypoglycemic. But even that by itself would be a huge step forward. All of these things, and we can come back and talk more about them, are about what's happening to you right now, or maybe what just happened to you. Event prediction is the next level after that. That's you are going to have X happen to you in the future, or your chances of having X happen to you have changed in some way. So, you can imagine going to that next level, but that is even more complicated. And in some of the health areas has real ethical issues associated with it, because if you know that something could happen and then you have to prevent it, then you don't really know whether you were right or not, and it makes it hard to learn. So this is the prototype that's in testing at Stanford. Here's what the Ecg waveform looks like off the upper arm. You guys aren't maybe physiologists, but we're excessively proud about this because it's not supposed to be possible to get an Ecg waveform off of one side of the body. And it turns out with some fancy footwork it is possible.
Where do you put the sensors?
What?
Where do you put the sensors for the ECG?
Right there. It is entirely self-contained on one side of the body, which 100 years of physiologic or electrocardiologic study says is impossible. And it's because of a nice combination of our new perspectives and our general ignorance about how the human body works that we can go forward in places where people have decided it's not possible and find solutions.
So that's on the arm?
Yeah. Although it turns out to work in other places, which is pretty cool too. This is what the next version of the product looks like. One of the ways it will go on the body is to be adhered to the body with a simple patch that you can take off after a day. It will also have a wing and strap like the current version of the product does. I forgot to do this, but maybe you guys just want to pass this product around for those of you who haven't seen it.
What is this little hole there?
That's a heat flux sensor. We have a heat flux sensor there, but this is a different way of looking at heat flux that we're seriously playing around with. This is scheduled to be commercial in July, so we're sort of locking down the spec right now. We actually were just up for like 3 hours last night arguing about this thing, among others. We're looking at different ways either to put IOs on the product, or this actually we've already built. This is just a watch that talks wirelessly with the product so you can get a dashboard for your body in real time. It turns out, surprisingly, people don't actually want this. It is shocking. We can't believe it. We keep building this and showing it to our partners, and they think that's so cool, and they show it to their customers. People don't care. It's amazing. People can wait till later. We still don't entirely believe that it's true, but we've gotten a lot of feedback for several years that this is one of these sort of technologists, product people aren't always right. You really have to go ask the customers. You can't just guess for yourself. Yeah?
That kind of brings the question, what are you looking for in market niches? Because clearly there's a fairly substantial portion of professional athletes, for example, or high fitness amateurs that pay good money to get fairly instantaneous feedback from instrumentation like that.
Yes, those people would like instantaneous feedback. Those same people, as soon as you start talking to them, say, oh, could I have lactic acid build up in my muscles? And they have 1,000 things they want. They're surprisingly unrealistic about what they want. It's also quite a small market. So you're exactly right, and that's not the only area. There are certainly niche areas where people would want this. But because our business is trying to build the operating system as effectively as possible, we're trying to get the low-hanging fruit first. And this one, it turns out, appeals to everybody in principle, but only to certain subsets in practice. And why? I don't know. We can talk about that more.
Do you think it could be related to the kind of information that you're presenting in real time and both, the interface of that information and also the information itself? Maybe they are not interested in knowing their heart rate as a number, but maybe some information derived from the heart rate.
Right. Well, this is actually calories burned per day. We're certainly clear on the fact that heart rate created its own glass ceiling because people don't really know what to do with it. But I'll get to you in just a sec. What we believe the real problem with this is, you have to wear another product, and that kills wearability. It adds cost, and cost is a real issue in the real world. You are asking them, when you put something in their face, it can be very exciting. It also reminds them that it's in their lives. And one of the powerful things, how many people here have worn an armband? Okay, we're batting 50% then on people. I take it you did not have a rash.
No.
Okay. Good, 50%, all right. Most people, absent a rash, have the experience that it fades into the background of their life. They forget that they have it on. Did you sort of have that experience where it wasn't sort of like carrying a backpack around? It was just sort of was something on your body that you forgot about after a while?
Yeah, but I think I'm not maybe the average user because I was very curious to know what my data was.
Right, but it turns out, or whatever, I'm speculating here, but we believe that part of the issue is that by bringing it into the forefront of their minds, it may have some negative implications about wearability as well. Yeah?
From experience with such a watch at Microsoft, I suspect a big reason that these watches are very big and very geeky, and they lose effectively all the women and, I don't know, 75% of the men just on that count. Forget everything else.
It could be. I don't know. You tell me. I don't know if that looks very big and geeky, but...
How many women would be willing to wear such a watch, regardless of anything else?
Okay. Fair enough. So let's talk about someone who can't complain about the thing that's put on their body. So this is the size of like a quarter, maybe a nickel. It's shaped a little bit differently. You adhere it onto a baby, and it's watching the baby. It's like an armband. It just doesn't happen to go on the baby's arm. And it can see things. The first application that we've been building is a temperature application instead of, how many people here have kids? How many people here have done the anal probe at 3 in the morning when they really wish they didn't have to wake their baby up? I mean, everyone who has a baby has. And you're like, oh, I just got him asleep. I can't wake him up again, but he had a fever, and should I give him more Motrin? And you would pay $100 one time not to have to wake them up. One time, let alone to be able to do it repeatedly. So it's on the skin. Yeah, that's sort of ghosted so you can see it, because it goes actually in the femoral region under the diaper, just kind of right here.
It doesn't work on the arm?
It could work on the arm, but the heat issues are different in different parts of the body. Plus, under the diaper has other opportunity for seeing when they've wet themselves and things like that. So there are a number of reasons why here or a little bit lower is the right place to do it. And then to send it like a sound monitor to a reader somewhere in the house and just see what their temperature currently is. And this temperature, by the way, is already better that we have in this product. It's already better than tympanic or axillary under your arm. In fact, it is arguably better than rectal. The problem is as soon as you start moving around, rectal is sort of the gold standard, but as soon as you have these kids start moving around at all, the thing sort of wiggles inside the kid, and it's not very reliable anymore. So this, we're not even sure what to gold standard it against. Well, anyway, this turns out to be compelling for first-time moms and dads, I suppose, in particular. And this is another example of how human physiological information can be instantiated not just in a doctory kind of way. Another one, other end of the extreme, you know, mom is wearing something like that patch. Maybe it's on her arm. Maybe it's over her chest instead. And if mom is okay, send an SMS message to her son. You know, most elderly people have as their primary caregiver a relative, not a professional. Send that SMS message that says, Mom's okay. That right there is a consumable piece of information of tremendous value. And if mom has been in bed for the last 30 hours, maybe her respiration's fine, maybe her heart rate's fine. This is a soft vital sign. It's a new vital sign. It's not classically thought of as a vital sign, but if your mother has been in bed for 30 hours, it's probably a surrogate for pain or depression or something like that, and someone should go check on her, and that SMS message is also valuable. And by the way, these things are all real today. This one's actually sort of the most prototypey of them. This one we're already selling, for example, where the armband acts as a hub for other kinds of information like glucometers and then sends the information to a home hub, a tiny little thing like a hockey puck, which either plugs into a phone line or through CDMA sends information to a server which then can be served up to something like a disease management center, anyone who'd be watching over somebody else. Yeah?
Wireless communication you have on it?
You know, like the length of this room, if there isn't any interference, it's a little bit less than Bluetooth, but, you know, realistically, it's meant to be more of a body LAN. It's an in-room kind of thing. This is different. It's not the same wireless because it has to go through several layers of drywall, but this kind of thing is meant to do this. It's a body LAN. And so it's low-power Bluetooth in the 900 megahertz range.
You don't need another device that hook it up to the...
Right, but this can still send, you know, through the house, and we have a different protocol for this, and then this has a CDMA chip in it, which sends out over long distances, obviously. Anyway,
the armband already has the radio.
The armband has a wireless transceiver, so it can receive information, it can send information. Mm-hmm. We're an intellectual property house, just to sort of round out this picture. So we offer to our partners some pretty exciting opportunities to be the only people doing some of this in their spaces. We're growing at the right kind of a rate, so the stuff that I've been telling you is actually working from a business perspective as well as a technology perspective. And in summary, I'd love to get some more questions, but the way we think about what we're doing is creating the opportunity for personal health tools first, and really personal body information tools or human state management. If you had, you know, being a little far out, a theater full of people and 5% of them had, let's say, armbands on, would you tweak the volume or maybe even change the plot line to maximize something about this subset of the people, assuming that they were representative of the whole crowd? You know, human state management is anything where you are trying to change people's states and individual states or a group of people's states based on something you know about their body now that you can have the information. Yeah?
I'm just curious, how soon like the battery needs to be recharged?
Well, it's 2 weeks of continuous wear, so if you wore it 24 hours a day, you'd need to replace the AAA about every 2 weeks. Mm-hmm. If you were to wear it 12 hours a day, you'd maybe once a month.
Okay, so the new prototype also uses AAA batteries?
No, the new, well, we're going to probably do it both ways. We're making 2 versions of the next version of our product, but this one is going to have a lithium-ion, or at least this design has a lithium-ion large coin cell in it, and it's probably going to have about a week's worth of realistic life, and it'll be rechargeable in about an hour and a half. That's looking like the spec we're living with. Another question over here? Yeah.
I have a question about the Wi-Fi or any kind of wireless transmission between, say, the baby and the actual monitor. Has that been a problem because of the radio transmission of devices and people don't want that kind of stuff near their kid?
Now, you know, a sound monitor creates the exact same wireless stuff. So I'll tell you, we are having a challenge with, let's go back to the baby here for a second. The real challenge that we're having is when the baby rolls over and there's a big bag of water on top of this little thing that barely has any antenna at all. It's just hard to send. So that's actually a real technical challenge that we're in the middle of overcoming right now. But people's, your cordless phone is right next to your baby and you don't freak out. The sound monitor is sitting right by the baby and that's sending. There are toys that this same baby is playing with that run on the exact same frequencies this does. So people, at least in our focus groups, that's not been their concern. They want to be satisfied that it's at least as accurate. They want, one of the things that they care the most about is warm-up time. They don't want to wait 20 minutes for an answer. They'll wait a minute or two, but they won't wait 20 minutes. So how fast can you get to the right answer with something like this? Just to give you an example, choking actually is something, this needs to be big enough that the baby won't choke on it. That's a real concern. But the wireless hasn't turned out to be. Now, there is that problem I just described about the baby rolling over. Though, interestingly, I think it was maybe it was you, Dave, pointed out recently that that's a potential signal for us that we can see when the baby is lying on its stomach if the signal goes away. And so, in a way, it's information as well as a problem. Yeah?
You have all these files on your servers. Have you yet had a subpoena on them or one of these Patriot Act search warrants?
No?
You will.
Okay. You know what? Honestly, I don't know what people would do with it since we keep anonymized data. I mean, good luck to them.
You do anonymize.
What?
You do anonymize.
Yes. So, I mean, really, we barely, it takes a lot of work for us to figure out what to do with the data. I don't really know what the bad guys would do with it.
Well, if it's anonymized, you said you do keep a lot of demographic information, though, right?
Right.
So it's anonymized within the demographic. Is that correct?
Yeah. I mean, height, age, weight, and sex, but we don't keep your name, we don't keep where you live. It's irrelevant to our
I understand that, but I mean, as your demographics become more and more elaborate, then the anonymity becomes...
That is potentially an argument for either not having those be more substantial, more nuanced, or for keeping them in separate databases. There are HIPAA policies for separating your data pools in certain ways to promote safety in that data. Okay.
But if you want to send information back to the patient, you have to know who they are and where they are and so on, right?
Right.
So somebody has...
But that doesn't have to be stored with the data, right? That applicant, because when they send in their requests, we know who's asking, and then we can give them their data back. Dave, you want to give him the sort of next level down?
Right. Obviously, we have to know who to send the data back to. When somebody logs in and they want to see their energy balance over the last couple of weeks, we have to know who to send it back to. In reality, we do anonymize the data when my group is doing the data mining on it. We don't know which subject is which. Whenever we present anything, it's always aggregate and anonymized. But we're facing the same kind of problem that a lot of people are with this data. If somebody were to subpoena, John Doe's records from Palo Alto, we could find out who they are. We could probably get that out of our database. We might have to serve it up. Thankfully, the law enforcement folks don't trust this kind of data yet, but I could easily foresee a future where they'd want to know, hey, was this person sleeping as they said they were in their alibi at this time, or were they out moving around?
Yeah.
That kind of suggests a substantial market for cranky people like me who would pay you, say, money to not have you, basically it's anonymized as it comes out of me. So it never goes to you at all. It goes to a local server that I control. It never gets shipped off to you.
And we actually already sell a version of those for scientific research. Gordon Bell, anyone else who's bought them from us for scientific research at Microsoft and anywhere else. Typically, because of IRB rules, the internal review boards, they want the data in-house. They have issues where they're going to say, I'm going to publish about you. I'll share the data with you afterwards because I love the idea, this project you have of making these algorithms better, but I can't give you the data beforehand, or there'll be questions about whether you somehow manipulated things or something. So I'm going to keep all the data here. So the software that we sell into scientific research is standalone on a PC for that exact reason. Now, you miss some of the opportunities of allowing us to update our algorithms every day, or if that's what's going on at Body Media, of doing this sort of network effect of having different people learn, or whatever. Your Pluto from the network effect, you'll get occasional tidbits from us, but it'll be much slower than everybody else. But as a scientific researcher, maybe that's fine for you.
So the current server that you sell with the R-band sends the data back to your servers for the average user, not for research. Oh.
That's right. And one of the reasons is because we don't particularly care to have our algorithms out there in the world. They're trade secrets of ours. we obfuscate them anyway, even though they're in-house. There's no reason to send them out in the world, to have the end users send them back to us. Again, part of Body Media's interest is doing the value of eBay, no offense to eBay, most of the value of eBay is that everybody's there. It's not all the other stuff that they've done. That's like 5% of the value. The real value of eBay is just everybody's there. We're trying to do that same thing for human physiological data, having people enjoy opportunity from each other, and we're facilitating that with these statistical machine learning tools. So I'm asking you for a trade. You have to trust me. You have to leave your data with me. I'm not going to give it to anybody else. I'm going to use what all of you are giving to me to make algorithms better for all of you, so that the more of you use it, the faster this thing becomes valuable for all of you. It's a trade-off, and if you don't want to engage in it, certainly I respect your right not to engage in that. But just like people, are comfortable with credit cards, even though everybody can see, it's trivial now to find out what people are buying. That's awfully invasive, more invasive in my mind than when you're asleep and when you're not asleep. But people, it's just worth it for them. And I would argue this is in the same category. But certainly, we're clear about what we're doing. And if you don't want to, it's okay. You don't have to.
So let me add one thing.
Sure.
One of the things that we're looking at, sort of in reference to your point, is only storing the sufficient statistics that you need to present the information to the user in a particular program. So in a weight loss program, we just store how many calories they've burned on a day. We don't store it by hour, we don't store it by minute, we don't store the full auto-journaling of what they did in that day, right? All of that is completely anonymized. So we can't reconnect the full data file with that user anymore, just the sufficient statistics. That gets rid of some of the issues.
The point is, I think you've got the point over there, which is somebody's going to subpoena the incoming data stream. That's where the privacy advocates are going to get really worried about that.
Sure.
And as long as that data stream is coming to you, I mean, it's basically like a pen register or wiretap or anything like that.
You know what? I respect these privacy issues, but let me tell you something from having stood up and talked to people like you and many others for 5 years. I get these questions all the time. You know who I don't get them from? End users. The press asks this. Smart people in every company I've ever visited ask this. But the end users just don't ask.
Because they don't get it. I'm sure you have some education on a person, they're not going to care.
No. What I mean is, even when you ask them, I can't get end users. I can't get Myrtle, who's 70 years old in Ohio, to say that this is a problem. And when she makes her list of concerns, it's like, is it going to be uncomfortable? Are my girlfriends going to laugh at me? These are the things on Myrtle's mind. Myrtle doesn't care whether her stuff is.
She hasn't had any kind of effect that's affected her or anybody she knows.
Okay.
I just think.
I'm submitting to you guys my experience.
But we're naive. We are naive. We've never been tracked medically, and so we don't know.
Have you presented this stuff in Europe, and do you have a different experience?
Yeah, they're taking it up in Europe faster. They have more sensitivity on the privacy front on some realms, but I think they also are more realistic on a number of fronts. So there's just a bunch of weird stuff about what you can ask for in email and other things. I would really say it's sort of apples to oranges in our experience. In some ways, they're more wound up about it. In some ways, they're a lot less.
I have a question. The information that you gather, and you say you improve the product as you move along, or the potential. Can you give us an example of how you may have already done that?
Improving things from.
So you gather information, which you then analyze, or whatever you do with it, and then you improve the product, and then.
Sure, I'll give you a couple examples that are underway right now, just as sort of because they're top of mind. Dave and I were talking about them yesterday. Here's an example. We make a new version of an algorithm, any algorithm, all of our algorithms. One of the things that we would like to do is we know how our old algorithm responded on unlabeled data. Even if we don't know what the right answer is, we ran our old algorithm out in the real world and got values X, Y, and Z. Now we take the new algorithm and run it on all that same data. And if it's wildly different on any of that data, that's a sign to us that there's a problem. So there's an example where we're using it as a sanity check. Here's an example. There's a lot of intra-person regularity. And for a long time, we've been very careful when we do our machine learning in-house to do our cross-validation. I don't know how many of you are comfortable with cross-validation, but Cross-validation, basically hold down a little bit of it, learn on this stuff, test on this bit, put that back in the pool, hold out a different bit, and by doing that enough different ways, you can train on the whole thing and know how you perform on the whole thing because you've held it out in different pieces. We're very careful to hold out it by person and not by session or by minute because there's too much intra-person regularity. But for that same reason, we're now looking at all of this unlabeled data to learn more sophisticated models of intra-person regularity, how people's circadian rhythm of their temperature goes up and down over the course of a day. Because when we learn those general models, we can use those, to your point, to get better on any individual separately. We're actually working on an expectation maximization routine. This is just getting traction now, but taking our current algorithms, taking them to our unlabeled data, saying, okay, we think they were walking there, we were jogging there, they were sleeping there, they were driving there, whatever that set of things is. This is our predictions. They may be wrong. There's noise in our predictions, of course, right? But we're going to pretend they're right. Then we're going to take those and put them back in our pool as though they were labeled data, learn on all of that, and then see how we do, again, doing this holdout set, see whether we do better on the stuff we know the right answer to. And if we do even a tiny bit better, you can repeat this process over and over again. And every time you get slightly better, you get slightly better labels out in the real world, which then you can treat as slightly better labels in your learning process. And you do this a number of times, and you sort of converge within the noise in the distribution that you're looking at. So those are a couple different examples. Oh, no, wait. Let me give you one more, because I think it's another cool example. Sometimes you don't know what the label is, but you know something about what the label has to be like. Women ovulate once a month, more or less, spaced about a month apart. So even if we were trying to learn an algorithm for when women ovulate, and there's reason to think that we could do this now that we're seeing core body temperature more accurately, looking at these basal spikes, and maybe something else about them as well. If an algorithm comes out and says she's ovulating every day, we know that's wrong. And if it says she's ovulating once a year, we know that's wrong. If it says, like, you know, it's getting 12 a year, but they're all like stacked up in January, that's bad too, right? So there are ways of implying labels into the unlabeled data. So these are all different ways of coming at this huge, rapidly growing pile of aggregate data, not having to know anything about the individual people, and pulling a lot of value out of it, and especially being able to turn it over again and again.
Let me give one example of one that's in the current version of the product, which is all of our data with metabolic carts is taken from lab data. People don't do the same things in the lab that they do when they're living their lives. It's very hard to get somebody snowboarding hooked up to a metabolic cart, right? It's very hard to get the right percentages even of people doing what they do in their real lives to do that in the lab. So one thing that we do is we use this data that we have coming in on our servers to get the right percentages of what people do in their actual days. Right? If you look in the literature, it's very hard to find a good study of what percentage of time people spend resting, exercising, working, etc. People have tried to do those studies, and they're all based on recall. Right? Stick a monitor on them. With our monitor, we have very good estimates of what people do throughout their day, and we adjust our error estimates for energy expenditure accordingly to have the best mapping from the lab data to the real world.
Yeah.
I noticed your financial slide has no numbers. Is there a backup version with numbers on it?
Sure, I have it backed up in case it's subpoenaed. Yeah, one of the privileges of being a private company is we don't have to give that. I think what's relevant for this talk is, we were venture backed. We're out of that phase. We're self-sustaining now, so we're not at Microsoft and we're not 3 people in a garage. We're somewhere in between. And that characterizes us, which I think is relevant to this discussion. But whether we're making $5 million a year or $50 million a year is sort of, I'm sure it's interesting, but probably a subject for a different crowd than this. Yeah.
I had 2 questions. One was, I was just wondering what your thoughts on the scalability of this whole architecture, reporting back the data to the central server and then pushing the response back down. Like, in your wildest dreams, say everyone in America took one of these, how do you think your system would scale now? And my other small question, how hard is it for an end user to coordinate these devices? You talk a lot about wireless configuration and user interface. Does it just configure itself, or what's it?
It's out of the box.
Okay.
So the answer to the second question is much easier. There's zero coordination. Our mantra is if Myrtle has to have a manual, any manual, a one-page manual, it's too much. If there isn't even an on button on this, because we don't trust people to hit the on button. That's where we're coming from, because I think that's what you have to do in order to win in this space. Let me come back to the other one, your first question. It's a much harder question. In terms of actual scalability, I will say, and I'm sure I'm being completely flippant about this, that's not what we're worried about. I realize scaling is hard. But now this is back to kind of the privacy issue and kind of our explaining this deal that we're trying to make with people. I think that's our real challenge in terms of scaling. So let's look at this. This is information which is coming to mom in the kitchen. This is not connected to the rest of the world. And there's no obvious reason why she would, actually it's not obvious how she'd give us the information or why she would give us the information. I think our real challenge is, could we put a little cheap modem in there? Sure. That just plugs into a phone line? Yeah, technically it's doable. I think the cost could be justified. Frankly, we'd cover the cost. She wouldn't even have to pay more. The challenge is helping her understand the following. If you want to monitor your baby, great. And this is already more accurate than anything else you can get. But if you plug this into the phone line and you're willing to share with us the data from your baby, in exchange, we will upload to you the newest algorithms that we have from everyone else who is uploading their thing. It's the same network effect. If you're willing to join the network, and this is a privacy issue, you have to be okay, and some people won't be okay clicking into the network. But if you will, we'll give you the benefits of being in the network. And I think the challenge that I'm sort of most fixated on is how to help inspire people that that's a good trade. That's my scalability worry, not the technical scalability.
Well, I'm kind of a technical person, so I was just curious. And I wasn't criticizing it. I was just curious on if you had run into problems already. For example, running your machine learning algorithms, are they taking hours, days, weeks?
Oh, that's a good question. I mean, we're already, Dave and I were talking about this last night. We're at a place where when we subsample our data, it already crashes MATLAB. I mean, we don't even know we have to write our own tools now. I mean,
we're backing up data and dealing with data in terabytes now per day. And so that starts becoming a real scalability question, technically. On the machine learning side, yeah, we break most tools.
Though even on the scalability side, I would say we're having more of a problem trying to hire people fast enough to make sense of all of the different things that we can go at than we even are backing up the data. Right.
Do you have a special version that lets people outside the lab input what they're doing or confirm if it asks them what they're doing?
Yeah, there are two different versions of that. I mean, one is, who has the product here, just so you can see an example of it. Anyone? Someone? Oh, here you go. Just toss it. So, right? That pressing of the button just recorded that it pressed the button. So researchers sometimes will say, here, go wear this out in the real world. And when you feel pain, let's say, press it once for a little bit of pain, twice a little bit more, 3 a little bit more, 4 a little bit more, 5 I'm about to die, that kind of thing. And then what the researcher gets is this double, single, triple click messaging, which is stamped into their data, which the researcher knows because he just told him that's a pain indicator. For somebody else, it's just press this every time you think about having a cigarette. Or, you know, when we have people annotate data, we give them little mnemonics like CAR, C-A-R, C-A-R. You press it 3 times when you get into the car, press it 3 times when you get out of the car, and then when later you go back to annotate the data, you'll know that's when you were in the car, and you have these nice timestamps there. So that's a way of giving people a little language in something, and again, this is a big button, and it's well depressed, so you can feel it through your clothes. Well, you can't hear, but I actually just pressed mine. So that's a way of doing it. We also support annotation and other kinds of manual entry for nutrition and other things outside of the laboratory environment. But
like on a PC? Or?
Yeah, exactly. Anything else?
How do these do going through airport security?
Well, Well, I don't know if we should all worry, but they don't set off the security. So I wore mine through recently. I don't know if you guys did.
Just Dallas, if you wear one on each arm, which I've been doing for some testing, it sets it off. But only in Dallas. It's the only airport.
And did you try it with just one?
No, because I only flew back from Dallas once. So.
But in any case, I mean, if you just say it's a health monitor, they go, okay. And we have something where if you hold it on. Hey, come on. That's their problem. We can't solve everything at the same time. We also have it, for example, you hold it down for, 5 seconds? Yeah, then it's an FAA installed thing. You hold it down for 5 seconds, it turns off the wireless. So you can be airport compliant or airline compliant.
Business model. How do you sell this to your venture capitalists as to how they'll make money? How are you making money?
How are we making money?
I'm just curious your business model.
The way we make money is I go to you, let's say just hypothetically you're Johnson & Johnson, right? And so I say, you guys are really good at this baby stuff, right? We've got this really great baby thing, right? Would you like to sell the baby thing? And you say, wow, pretty cool. And we say, well, we could put your name on the baby thing and you could go sell it. And really, that's what you do. You buy innovation. And what we do is we innovate. So we could be good friends. We make it, you sell it, and you're going to say, well, wait a second, Astro. This is sounding pretty good, but the truth is I don't really trust you guys to make this. Once you make the first 20,000 of them, show me how to do it, and I'll take a manufacturing license. And we say, okay, because we've got really good intellectual property. So we say, please, you go, you make it, you sell it. You just send us a royalty. We're happy with that.
So do you have folks like Johnson & Johnson?
Sure. So Roche Diagnostics, for example, is selling our product in the clinical weight management market. Apex Fitness, where is it here? Apex Fitness, which is the largest distributor of, and 24-Hour Fitness, this is the largest distributor of weight loss, weight gain, and fitness programs in the United States. Over 500,000 new program members last year. So it's on the order of like Jenny Craig or Weight Watchers. Just most people don't know their names. We're selling these things, hundreds a month at this point, many hundreds a month, all over the world. And these are very high margin, as Microsoft knows, because the software is expensive associated with it. So, these are resellers. These are more like channel partners. This is also a channel partner. And as we go into each of these new markets, what we do is we make friends with large companies in the cardiac space, the diabetes space, infant monitoring. We make the products. You go sell it. You make the bulk of the money, but you share some of the money back with us. And because we have no sales and marketing overhead, and we've already done our investing, we have very rich returns, even when you're sharing a relatively small portion of it with us. And here's the one bad news, Johnson & Johnson. We're going to own everything, right? But we're going to give you an exclusive in your area. So you de facto, have access to our entire intellectual property portfolio in your area, infant monitoring, again, hypothetically, right? But everything we learn here, if we can take it to elderly care, hey, that's our business. And if you want elderly care, then step up, tell us you want to ship something into elderly care, and we'll make another deal with you in that space. And because there's so many places that we can go, and there's so much underlying leverage underneath it, because it is an operating system, it is the same physiologic information services, our venture capitalists are quite supportive of this business model. Yeah?
Have you had any interest, or anyone who's expressed interest for military applications of this?
The military. And I'm sorry, that sounded a lot more flippant than I meant it to be. The people who are in the field are dying for this. Literally. And I can't tell you, the Special Forces guys are rude to us. They're so angry that they don't have it already. And the Marines are the same way. The people who do research in this area are not interested. I'm not even going to say that sentence because that's not fair. The people who do research in this area are paid to think about things 15 years from now. Mm-hmm. Particularly DARPA. They have the money that is supposed to be going to help these people, but they're not interested unless it's really basic, over-the-horizon science. And so when we say, we have something here which in 12 months could be saving rangers in the field. The rangers flip out. But the people at DARPA say, yeah, we're interested in this pill that can cause them to be supermen so they can go without food or sleep for a week. I'm serious. They're working on it, and they'll probably have it working in 20 years. But it doesn't do the rangers any good right now. It's disappointing because, first of all, they see a product and they believe it's not science anymore, which is hopelessly untrue. Sadly, there's an awful lot of science that we have to do every day at Body Media. It's just not how they like to think of it, and all that money gets funneled to those other places. So actually, we've had much better luck going directly to the federal government and getting appropriations from Congress to us, where they just say, we're really frustrated that people aren't pushing this harder. You go work on that. Here's $1 million of taxpayer money. It's not going to go through DARPA because you should be working on it, and if they're looking too far into the future, here, go fast. So we actually are interacting with a lot of different military groups, but there's an interesting tension there. And Ivo can, yeah, Scott.
Have you thought about gathering location information, GPS, and what you would do with it if you had it?
We have. We've looked at a little bit at using GPS as just a basic sensor that we could use, like we use some of these other sensors. And we haven't had a lot of success in getting these particular kinds of algorithms to be better, because we're not in the location business per se. I guess we could get into the location business. That's one thing. I know of at least one person who is gathering GPS data with our stuff right now and sending it back to us. So we have that data in-house. I don't know that we've actually analyzed much of it yet. Sandia National Labs was doing the same thing before, but that was a couple of years ago. Honestly, you know, as AGPS is out there, it's getting smaller, lower power, works a little bit better indoors. I think there's more and more opportunity for that, but I see it as sort of a disjoint set of things which at some point can land in the armband, but because we haven't found a lot of value in how we would use the location information, it ranks there with like a muffled sound microphone inside here where you can sort of tell they're outside or inside, whether they're alone or with other people. You know, we're just not in the location business, but it's a good question. As we go into some of those things, it could be interesting.
It probably only be useful if you had very good mapping where you could tell kind of where people were. Oh, you're on the roads and you're doing the jiggly thing, so you're probably motoring, right?
Well, I'll give you an example. All the special forces guys say, we don't need anything else. They actually took some of these out recently to Okinawa in the Northern Territory, the Marine training ground in Japan, and sent 7 Marines out or 8 Marines out for a week, and it came back, and all 6 of them were still working. First time anything had come back working, even one of them, from the Marines in the Northern Territory. So they were blown away. And we said, well, what did you think of the data? And they said, we didn't even look at the data. We just wanted to know if it would turn on at the end of a week, because it's never done that before. So they said, this, when we showed them some of the data, they said, this is all we need. If you could just put GPS in here. That was actually their feedback to us. And we said, great. You know, write us a check for $500,000 and you can have 10,000 of these things. Or, you know, you have to pay for each of them afterwards. But write us a check. We're not going to do GPS just because we think it's cool. But if you think it's cool enough to write us a check, we'll put GPS in here for you. And then they say, ooh, could you go ask DARPA? We actually have no money. And that's where this sort of goes. But I think there's a lot of opportunities, like in assisted living and independent living, where GPS could be powerful. So that's kind of circling there. I would put it in the same category with the watch. We've been thinking about it for a long time. We get it conceptually. We haven't actually gotten anybody to bite on it yet. So it's sort of circling there as a possibility that's sort of never moved forward with us.
Have you thought of doing Bluetooth so you can take advantage of other device standards? Like, you know, if somebody already has a GPS device, you could be re-sampling it.
We thought about that. Bluetooth is higher power, so that's frustrating. It's a little bit more expensive, also a little frustrating. And, you know, when we placed our bets about wireless 5 years ago, everyone was talking about Bluetooth already, but there was just no Bluetooth to be had. And it's only now that there's some Bluetooth to be had. And even so, if you try to talk to cell phones, the only really good place to talk to something Bluetooth these days, it's semi-ubiquitous. You'd be surprised. You can talk to the phone, but you can't know what's going on with the phone because the operating systems inside the phone are still pretty locked down. So I think we're 2 or 3 years away from usefully, even if we had Bluetooth, going there. So I'll tell you, we're looking at Zigbee for the next version of our product. Okay. It's not about us being proprietary. We made ours our own thing because we just wanted it now and we couldn't wait. But we don't care if we give up our wireless. And so Zigbee, I think, has more of the right characteristics than Bluetooth.
It's comparable? Zigbee is comparable with what you have now in terms of performance?
No, it's higher bandwidth than what we have now. It's higher power, but not higher power per bit, which is all that really matters. The range is a little bit better with Zigbee. I don't think it's that different, is it?
Yeah,
it's about
some sensor message forwarding,
right.
Built
yeah,
in.
exactly.
It's very nice.
One more question. One of your first slides, I'm not sure if I caught it right. It looked like you had some more auxiliary sensors, like little patches.
Sure. Let me go back to that for a second. That's a good question. I sort of skipped over that. But
next one.
The concept is you have a hub that passes through your life with you. And sometimes when you stand on the weight scale in the morning, you not only see the data, but now the data is in your hub. When you go out for the day and you prick your finger, right, you're not in the home can't know about it, but your armband gathers that information. It gathers information, maybe a location, where you've been. It gathers information about how warm it was and all the places you were. It doesn't have to be medical information. It could also gather information from other sensors put on other places on your body. Since we're developing these patches anyway, why not make them as small as possible and have them talk to a processing unit? Actually, conceptually, that patch doesn't have to be a patch. It could be implanted inside you. So an artificial pancreas or an ICD or something like that, these little glucose meters that they have now that are sort of grain size they can put under your skin. The more of those that there are, that's not undoing wearable body monitoring. It's just proving the point, because those sensors aren't going to send the information very far, that you need something on the outside of your body to gather that information. So we think we're going to be heading more and more towards being a hub for information and an analyzer of the information, less and less a hardware company or a sensor company as the sensors start to work themselves into people's bodies in other ways.
But right now, there's not a supported ecosystem of...
No, right now, because it's our own protocol, we do, there is weight, you can buy a weight scale, but you have to buy it from us. It's a Tanita weight scale, but you have to buy it from us. There is a glucose meter, there is a blood pressure cuff, there is a pulse oximeter. You can buy those things from us and they talk to this, but there isn't an ecosystem that other people are creating yet. All right, thanks, guys. There you go.
Great, thank you. So I told you a lot of questions.
Let's go, it was perfect.
Yeah.